Dilation! Welcome back, friends, to my transformation cast. We started with translations. We moved on to reflections, then rotations, and now we've met our final boss battle, dilations, which is a transformation in which a figure is enlarged or shrunk. And much like rotations, it's got a center of dilation. In a rotation, think of the center of a clock. The hands rotate around it. In this case, it's more of a projection point. Think of the light bulb in a movie projector. It goes through the film and then makes a huge movie-sized movie. That's how movies work, right? Anyway, in our case, we will always use the origin as our center of dilation because we don't want to have to get compasses and all that nonsense out. The biggest thing about dilation is its scale factor, and this is the ratio between the original image and the new bigger image or smaller image, and we call this K. K is your best friend when making dilations, and when K is greater than 1, that means the image is getting bigger. Big K, bigger image. Now, when K is in between 0 and 1, I'm thinking of fractions, decimals. That means that the image is getting smaller. So, less than 1, small image. Bigger than 1, big image. I'm sure a lot of you just asked, what if K was negative? Well, you nerd, if K is negative, we get a dilation. Just like normal. If it's -2, it's still twice as big, but we also rotate the whole thing. Since we are going to be multiplying the entire plot times a negative, it's going to flip it just like it would in a 180 rotation. And here it is, the bread and butter. We've got, if I were to dilate point A by a scale factor of K, then I would take the point XY, which is our A, and multiply both X and Y by our scale factor. And that's it. One rule, #party horn. All right, friends, we've been having a lot of fun here, but let's actually do one. I'm going to look at the points M, E, R, and right now I'm just going to write them on down. So first I get M is at 2, 6. I get E is at 6, 2, and R is at 2, 2. I know these numbers are sloppy, but I've done worse. Next up, I'm going to look here. Dilate with a scale factor of 2. This means my K is, that's right, 2. People have been asking, where do you get the scale factors from? Well, they should just be in the question. In this case, it happens to be 2. So when I do 2, I'm going to take all my X's and all my Y's, and I'm going to multiply them by 2. So I get 2 times 2 is 4. 6 times 2 is 12. I get 6 times 2 again is 12. And 2 times 2 is still 4. And then 2 times 2 twice is 4 and 4. Again, I'm sorry that this is not legible, but I'm trying my hardest, guys, okay? I'm going to plot these now. 4, 12. This one's off the charts. That's my M prime. I get 12. 4 should be like here-ish. And then I get 4, 4 is going to be right here. That's my R prime. And now I'm going to make a very perfect triangle. Holy crap. It isn't the worst. God, I deserve a medal. Now, let's go back. This was when a scale factor was K equals 2. But what if we made a scale factor of 1/2? A, it's going to get smaller. And B, we do the same thing. I'm going to take all of my original X's and Y's, and I'm going to multiply them by 1/2. Let's do this one in green. This means my K is 1 over 2. Well, 1/2 of 2 is 1. 1/2 of 6 is 3. 3, 1, 1, 1. That one wasn't so bad. All right, these tiny confines are going to make this hard. But first up, I get M double prime is 1, 3. Right there-ish. M double prime. Then I get 3, 1, That's going to be E double prime, and then I get 1, 1 right here. That's going to be R double prime. Now, perfect triangle making. Wasn't the best, wasn't the worst, but that's the way the cookie crumbles. Now, if you notice, and this won't be perfect, I did this in class and it looked kind of cool. This time, better than I thought it'd be. You can see the projection from the origin, which is our center of dilation, is making these come out, right? All the lines are going to cross through the separate things. Notice that R, R prime, R double prime, those are all on the same line pretty much. Let's check out a negative dilation now. Okay, with this one, we're going to do a negative dilation. I'm going to use the exact same x's and y's for MER, and now in red, I'm going to go negative. Since it's negative, that means my K equals -2. Again, I am just getting this from the question. So let's see, if I multiply -2 times all of my original x's, I would get -4, -12. We're just going to go right outside the lines. -12, -4, and then -4, -4. I'm going to make these bigger next time, and I'm sorry. So there's -4, -12 would be down here. There's M prime. And then I've got -12, -4. That would be like over here-ish. E prime, double prime, or single prime, prime. And then 4 is going to be right here. That's going to be R prime. I'm going to make a perfect triangle yet again. Now, all I really want you to notice is we still get that line, right? It goes through the R primes R. It goes through the M's. And like I said before in the notes, when you do a negative dilation, you get not only the size change, I still get a 2 times as big triangle, but I also get a 180 rotation. So it makes sense because our M used to be on top, 180, I go 90, 180, now M is down here on the bottom. Wow, this all makes so much sense.